Thanks all for coming. What a good crowd here. Congrats to the organizers. Mark, so just explain who you are and explain Aethir.
Sure. Hello, everyone. Mark Rydon here, co-founder of Aethir. At Aethir, we build distributed GPU infrastructure. You can think of us like an AWS or a Google Cloud, except we focus exclusively on GPUs, and we don't own any of the GPUs in our infrastructure. All of the GPUs are provided by our partners, whether they're tech companies or telcos or data centers, and we give them the ability to essentially take their underutilized equipment and then connect it into our infrastructure in a very frictionless way, and then redistribute that infrastructure back out into the market so that it can be matched with this global demand for AI resources.
Okay.
Hi, Evgeny, co-founder of Fluence. I just had a talk. Same as here, same as Aethir, but mostly CPUs and a little bit of GPUs that are coming. So decentralized cloud platform.
Yeah, hi, it's Henry, co-founder and CTO of Open Network. Open Network is an infrastructure that bridges high-performance compute resources like GPUs and CPUs from Aethir and Gensyn and everyone into the hands of developers, so they can build trustable and verifiable applications such as AI agents.
Hey everyone, Ben from Gensyn. We are very low-level machine learning infrastructure. Essentially, we connect up machine learning capable compute hardware, so GPUs, but also CPUs, TPUs, anything that can do machine learning operations, and allow it to be used as essentially one giant cluster. So instead of, as a machine learning engineer or a researcher, instead of using a specific data center or a specific cluster to train your AI model, you could use any device in the world or any set of the devices in the world. It could be a load of MacBooks, it could be a data center, it could be multiple data centers. And we handle all of the kind of low-level execution, communication, and verification of the work. So it can be entirely programmatic. Anyone can connect their device to the protocol and start providing compute. And anyone can use the protocol to use any subset of the entire world's compute hardware.
All right, great. So a lot of us are familiar with sort of centralized approaches to AI development. How does DePIN differ from that? And how is the kind of shape of AI development in DePIN different? Mark, you want to start?
Yeah, sure. I think the way that you look at developing AI in a centralized manner is generally quite expensive, very resource intensive, and somewhat exclusionary to the majority of builders, right? It's a sort of environment where those with the most resources have the best access to what's necessary to build high-performant AI. Right. That's why we see the best AI models existing within just a small number of really, really big tech companies. I think from a decentralized AI approach, certainly through the lens that Aethir looks at this challenge, it's about how do we redistribute resources to those builders in a way that we can get comparatively performant products from builders outside of just the big tech companies. So for us, it's very much about looking at the available compute out there, saying where are there pockets of inefficiency that we can then take that compute, use the blockchain, and redistribute it in a trustless manner such that builders can access that compute in a kind of a seamless manner. I think the unit economics of decentralized compute are quite different as well. Taking compute that wasn't necessarily purchased with a very specific purpose of kind of pumping that into a data center and having a return on investment in kind of a certain number of months. Now you can effectively look at it as, okay, how can I just get some money back? Or how can I not be losing money on this equipment because I've misforecast how much compute I need? So it's really about redistributing access and getting the power back into the hands of people outside of just a couple of big tech companies.
And which sort of aspects of AI is DePIN good for, do you think?
I think from my perspective, probably I'm in many angles, but maybe two angles to highlight. One is just the scale of AI models in general. Scale has won in machine learning basically every time anybody's kind of bet on it so far, and it still seems to be winning. If you can make your model bigger, then you can have a more performant model. The scaling limits that the centralized world are hitting now, though, are related to weird things like real estate and can you cool a data center of the size required to make something bigger, i.e. like the laws of physics stop you from creating a large enough data center. with decentralization, we can kind of take those limits off, and you replace that physical infrastructure with a virtual infrastructure, essentially. You just connect up all the distributed devices and you take off those scaling limits. Your scaling limits then become how many devices can we actually manufacture in the world, which I think gets us to the maximum scale humanity can actually achieve. So scale is one of the huge ones. Second one would be personalization for individuals. So this idea right now that we're all using this small number of centralized models created by a small number of companies, I think that's very rapidly going to change towards personalization of models for everyone. The performance improvements we'll see as actual consumers and users of these models will come from them knowing more about us and tailoring answers and kind of feedback to us personally. But that can only come if you can do the execution of those models locally and you can train them locally. And so consumers have access to some compute power locally, like your devices are reasonably powerful. But if you want a larger model, you then have to use outsourced compute somehow, and you'd be tied into an infrastructure if you were using outsourced compute that just came from one company. It also ties you to that company in terms of bias in their models, etc. If you have a completely open and free market infrastructure, every user can expand the amount of compute they need across that infrastructure without being tied into any one company. So it creates a much better experience for individual users.
I'm sort of interested by DeepSeek because it was known as this kind of Sputnik moment, and everyone thought that AI was this kind of centralized thing with these small number of companies. Does DeepSeek change the conversation around the decentralization of AI? Maybe DePIN. What do you think?
Yeah, I mean, like DeepSeek is definitely good. Like it's open sourced from the day one, right? It's a definitely good move and good moment for the whole AI industry, and it sort of like really put people in California at real stress. I think, but there's only one part of the picture here, right? So we need open source models for sure, but we also would like the infrastructure to be available and transparent and not owned by big clouds, like big corporations. Right, so because you need to run this DeepSeek somewhere, like you can run the smaller model on device, but still, like the biggest models, you still need to. I still need the cloud infra, sort of the somewhere in the cloud for you, like the big machine should still host this model, because essentially, like when we talk about integrating these models into consumer products. You cannot cover all the use cases on a device. Like even if this model is open source, even if like it's smaller, even if you download it to device, it's still not enough. You still do some stuff remotely with the server. I'm not sure if I answered the questions.
Sounded pretty good to me. What about what would you say are the main technical challenges of decentralized AI versus centralized model? Do you want to take that, Henry?
Yeah, I think it's about the access to base models, like how DeepSeek is changing the game. Because, well, as a distilled model, it wouldn't exist without like GPTs, like previous large models, and just like how Ben and Evgeny just described how the future of AI is going to be personal and it's going to be local, on premise, on devices. Without distilled models, it's not possible. So DeepSeek actually enabled this future, like brings this future one step closer. It shows us that we can still distill small models. Not although DeepSeek is not that small, but it's possible we can further distill the models from a teacher model like GPT or Llama or any other models and make it specific for a very small use case, like for example, predict your health condition, and it only has to know your personal medical records on your devices, and it's very possible because the storage is relatively cheap comparing to GPUs. We can have a really large storage devices, like your future iPhone might be 10 terabytes for storage. Then it has like 100 different small distilled models like DeepSeek, and each of them does one specific job. And together you can have all the different tasks processed by your personal devices locally. And also you can have DePIN servers processing those larger requests that's not possible to be processed by your personal devices. And I think how do we solve the interaction between the cloud server that you trust and powerful local distributed model? That's one of the biggest challenges I see.
Anyone else, Ben?
Yeah, I think we think about three main challenges, and we think very specifically about just low-level machine learning operations. But if you're wanting to do machine learning across these distributed devices, you essentially have to solve heterogeneity of compute. So you've got loads of different types of devices that you want to make compatible in some way. So you've got NVIDIA GPUs, which we're probably all familiar with. They're the kind of bottleneck in AI right now. There's tons of other chips that you could be using, but there's a software stack problem. NVIDIA has a library called CUDA, which is very performant. It's also baked into basically every machine learning library. Other manufacturers don't necessarily have that. And so it makes it harder to use those devices. So if you do connect up a decentralized network of compute, you need to somehow create a compatibility between those NVIDIA devices and all of those other devices. The second one is communication. So you've got weird latency and bandwidth issues if you try and train a machine learning model across like 1,000 people's consumer broadband connections instead of one data center with really fast interconnects inside it and then a really good kind of broadband connection out to the rest of the world. You can solve those issues, but you have to change the way you do machine learning. So it creates kind of higher level issues that you need to change if you're a machine learning engineer or developer. The final issue is verification or trust. So if you do want to connect up devices from everybody here, you can't go and kind of establish trust with everybody here. It's very expensive to do that. You have to sign legal contracts. You have to know who people are. You have to do KYC, etc. It just is puts a huge scaling limit on top of that problem. So you need to solve that programmatically, and that's why kind of blockchain gives us a great solution. It gives us this source of truth by getting everybody in here to agree on something, and that allows us to terminate any disputes between people at a chain, which is fully programmatic, rather than in the courts via legal contracts and things like that. So the real kind of power of DePIN to us is changing all of those, it's solving all of those problems, and it's then creating this programmatic trust layer instead of having to have that human world trust layer, which is just really expensive to scale. Anything that requires a human is far more expensive than something that requires electricity. So if we can replace the human with electricity, i.e. making something programmatic, then we can take off those scaling limits.
I mean, are there any estimates for how many people are contributing to these DePIN networks so far in AI? Do we know?
I've honestly, I've got no idea. But I can tell you, for example, just the devices that are within our network that we've sold. For example, we have the Aethir Edge device, which is effectively an edge computing device that individuals can own that then operates as a node within our network, suitable for small language model adoption, agent applications. It can host cloud gaming and real-time rendering services, particularly well for mobile devices. And we see an increase in the requirement for edge-based computing over the next kind of couple of years. We've sold around 60,000 of those devices, and that's kind of at a direct-to-distributor relationship as opposed to B2C. We haven't kind of opened the funnel for direct kind of consumer purchasing. But we also, on top of that, have around 80, almost just under 100,000 GPUs that are contributing to our network in over 60 different countries. So I think that DePIN has an incredible use case, right? It's really just about matching that use case with people that are willing to kind of contribute. Also, the great thing about DePIN is it's so easy to understand, right? I feel like of all of the different topics in crypto, explaining to people a DePIN product is the one that kind of clicks the quickest.
Yeah, I just wanted to add that one of the useful exercises here is to compare to Vast AI, which is Web 2 GPU marketplace, and I think they reported a couple of years ago $200 million IRR. I'm not sure where they are now, but essentially you can estimate sort of let's say like a average GPU owner that just casually rents it out from home earns like maybe a few $1,000s per year. So essentially, that's a scale of tens of thousands of people participating in this Web2 marketplace, and imagine with like token incentives how we can scale it in Web3.
What do you think, Matt?
I think I'd just add one final piece, which is a lot of the thinking in DePIN right now is that people will very deliberately offer out access to their hardware. So they'll run some software, they'll know that they're receiving a yield in some way, they'll get that in tokens, and they'll very deliberately be participants. I think the real unlock comes when people don't even really know that that's happening. So when you can kind of OEM bundle the DePIN software into the devices, all the user knows is, hey, my MacBook is slightly cheaper now. Like, I don't really know why. I know that I plug it in at night and it does something, but like I have nothing to do with it. And then the cost is 50% lower than it used to be. And there's companies behind the scenes that will provide that experience. There's like DeFi integrations that can exist that kind of pay the upfront cost and then take the yield so that the user pays less. But I think once we get all of that bundling done, that's when it'll really scale. But in order to do that, you have to build that really low level infrastructure. It can't just be the interface where somebody comes in and kind of downloads some software and runs it and knows they're provisioning the network. It needs to be baked into the hardware itself as and when it's shipped. And I think when we do that, we'll see it across so many different devices. It won't just be the high-end GPUs and the MacBooks. It might even be the smart TVs and things like that. I think we're going to have a bit of a race, or we are in a race right now, to the kind of brain in every home. Every big device manufacturer is trying to be the one that gets the very powerful AI device into people's homes to run models for them. And once you do that, you kind of capture that sort of like family as a user base. Those devices are really expensive, so those companies have to convince families to spend $10,000 on this like really powerful TV. It's very hard for them to do that, but there's coming, I think, a kind of iPhone moment for those devices where the iPhone was really successful because you could pay $30 or $50 a month for it instead of having to pay like $1,500 up front. I think the same needs to exist for these devices, and DePIN provides a way that you can do that. If you bundle the low-level software behind the scenes, abstract it from the user, they just know that they plug it in and, hey, it costs this amount of money. I don't really know what it's doing.
So it's going to pay off the high cost of the machinery.
Yes.
Yeah.
Yeah. It's like a subsidy in the end of the day.
Henry, what do you think about that idea?
Oh, I think that's a brilliant idea, but I think we're still very far away from that. It sounds really good. Instead of streaming ads, we are now selling our idle compute. Like, we are sitting here, our laptops and our phones are not doing anything, so they probably better, be making some yield for us.
Exactly. What about particular kind of sectors, industry sectors, finance, healthcare, gaming, supply chains? What are they going to be the main sectors that are going to take advantage of decentralized AI systems? Who wants to take that?
I think first it's just direct to consumer AI. That's the kind of tip of the spear for everything. The way we think about it is basically everything will take advantage of AI in some way. It's an enabling technology that can be applied anywhere there is digital data and anywhere that people are doing digital knowledge work. And so that will happen inevitably. If DePIN didn't exist and decentralization didn't exist, it would happen anyway. It would just happen in a centralized way. There'd be loads of issues that we've talked about up here. There'd be like centralized biases, there'd be power accrual, there'd be large costs for the consumer, etc. So we changed that. But I think AI is just inevitable in basically every digital industry at this point. It's in a productization cycle right now. For a long time, it was sitting in kind of research, and then it was in sort of scaling and engineering, and now it's in productization. So people just have to figure out, how can I actually apply this to my problem? And do I have the tools to do it as a semi-non-technical user? And I think we're starting to get those kind of like no-code style tools that will make it actually scale across industries. Because for a while, it's been this thing that you need an expert to actually apply. And then you need to find that expert, put them with somebody with the industry knowledge, and then sort of combine that. It's very hard to do. It becomes a lot easier once it's productized.
Great. Should we take a couple of questions from the audience? Anyone want to do a question?
So, hello, this is Michelle from IOS Networks. So, we are also your DePIN ecosystem customers. So, my question is that actually, most of the DePIN applications, they want to deploy their applications on the DePIN networks. First question will be raised by the data privacy. So, how you can resolve this kind of result? So, actually, for example, for Europe, it's GDPR. For the others, actually define, designs, all the project come to me. So Michelle, how you can use a very secure language. Another one is for the scalability. So actually you have all the edge nodes, even for the inference, but for the training, you need still big clusters. So how you can use, but for example, actually DeepSeek, right? So they use the data centers to make the training, but then when they come to use part of our DePIN networks, I think that actually edge nodes is not so efficient. So we need big clusters, but how we can merge perfectly with skyscrapers, for example, Amazon, Google's. So do we have some propositions? Thanks for so smart. Yeah.
I'll maybe skip the first question because we don't actually really touch the data layer, right? We're the hardware provider, so people just connect directly into the infrastructure, and then they have 100% control of that infrastructure in that box, and the data that's on site is not something that we see. Right, so just pretty much how you'd interact with an enterprise cloud provider and meeting their SLAs. But on the kind of scalability side, actually, I've totally forgot the question. Can you tell me the second question one more time?
Yeah, for scalability. Actually, so for example, the last model. For example, as a DeepSeek, so they also use the centralized computing clusters. So today we are engaged the discussion with DePIN, right? So actually we will call that Web3 is also the future. We will merge with Web2 infrastructure. It means that actually, for example, DeepSeek can they use part of the DePIN as their infrastructures to trainings, because actually these things are most of the DePIN project. We have edge nodes, but this edge nodes is not strong enough, right? They are still your big clusters to training. So how you can, for example, actually DePIN's most of the nodes come from their end users device lab, everything. So how we can make it, right? Yeah.
Yeah, I want to answer this question on in terms of Aethir, but then I think Ben will have a really good answer to this too. But for us, I think there's maybe a misnomer when we think about DePIN from a compute perspective. I think many people think DePIN or decentralized compute means only edge compute, and maybe that you also only can do distributed training, right? But actually, in networks like Aethir, for example, we have a large number of co-located a high-performance compute infrastructure, right? So even though, yes, you could come and utilize Aethir to target a hugely distributed amount of compute, not many people have a use case for a large amount of very distributed compute, right? Like you mentioned, you do need co-located equipment that can communicate in real time with adjacent machines to train and get great outcomes or cost-effective outcomes from model training. And within Aethir, we have, the largest high-performance compute clusters in crypto. We have the massive amount of H100s and H200s. So if you do want effectively a replicant of a centralized compute service, but just in a better, cheaper, more accessible manner, then that's exactly what you come and get from us.
Yeah, I think all I would say on this is centralized clusters are very useful for the specific work we've done in scaling machine learning over the past few years. It's kind of a similar situation to the fact that early on in computing, we all thought supercomputers were going to be the thing that you would run everything on. And quite quickly, we realized, yes, supercomputers are very useful for certain tasks, but distributed computing is very useful for other tasks. And scaling typically goes down a similar line. When you find a task that works in a performant way and you want to make it better, you scale it vertically, which is basically just throwing more resources at it and kind of scaling it in the simplest way possible. So you put all those resources in one place and you just see how big you can make the thing. And that's what machine learning has been doing for the past 5 years, basically. We're starting to hit the limits of that. But we're also starting to hit that kind of productization and real, true kind of world scaling of these technologies. When that happens, what we do is look at just the history of distributed systems. So the internet scaled in a very kind of fault tolerant way, a very robust way across many, many, many devices by just doing different techniques to the initial supercomputer scaling that kind of proved that it was possible. We think machine learning is just going to follow exactly the same path. We scale these models initially just to see what they can do by throwing resources at them. And then once we have real use cases out in the world, we scale them in a kind of horizontal way, distributed across devices. You can also think about that centralized scaling as being potentially just one way of doing it, but you can scale in a horizontal way. You can scale models using mixture of expert systems. You can scale them with communication between individual models where the communication itself is learned between the devices. At the moment, we just assume that every device just sends basically all the information to every other device. And you can think about that as just the most naive way of doing it. It's just like the first thing you would do. But machine learning is very powerful as a technology. If you kind of point its lens at itself and let it learn the way to do the communication, you can actually trim that down massively. And it becomes this like recurrent optimization process where it learns to use the resources it has available to itself. That's where we get really excited, because then the scaling limits are off. You can scale it as much as you want. So yeah, I would just kind of leave people with the centralized scaling is just the tip of the spear. What comes after it is that productization. And if you look at the history of the internet, we went through this before. We started vertical, we ended up scaling horizontally. We think the same thing will happen here.
So in the DePIN space, I think we hear a lot of the word people. People are providing resources. But what it really sounds like is like centers are providing resources, right? Industrial grade resources aren't normally in like people's houses. So I guess the question is, let's say I have a couple H100s at home. What's my reward generally on like a monthly basis for contributing to DePIN? Right? Is that even possible as an individual? Do I have to be a data center? Do I have to have industry grade infrastructure to be able to compute, to provide compute, not from like my edge devices, but from my H100s that I'm just like sitting on not using?
Yeah, if you don't mind, just quickly, one thing maybe generally DePIN is so cool because it's highly participatory, right? That's what kind of makes DePIN so exciting. But it also creates, in many cases, this artificial sort of ceiling, right? Because it's really difficult to find ways to meaningfully utilize that type of infrastructure in a way that can kind of meet the people and the companies and the organizations that are willing to pay for access to that service, right? So, for example, Aethir is an enterprise-grade only DePIN, right? Many people say that we're kind of like an Airbnb for GPUs, but actually we're more like a booking.com, right? Where instead of people's rooms in a home, right, we're aggregating hotel rooms in a hotel, right? So we aggregate, for example, enterprise-only compute. So if you had an H100 at home, it's highly likely that you wouldn't be able to meet the redundancies and the security and the safety requirements of equipment that would tick the boxes for an enterprise service buyer, right? So in that case, we wouldn't be able to onboard your compute into our network. But that's meant that our network kind of scales a little bit more slowly. It's a little bit more difficult to scale our network than it would be if we could just onboard compute, but it does create this great synergy between the compute we have in our network and the compute that's on demand within our kind of customer base. But that's just one approach to DePIN. It's the approach that we took, and it's different to most, I think.
Yeah, actually, just want to add, I think you can just earn roughly $1 per hour per H100 with like 50% utilization rate on average if you go to, at least on the Web2 platforms like Vast AI, because there's actually always shortage of H100s there in particular. On Web3, I think there is a couple of platforms where you also can, on like a DePIN platforms, where you can also publish your H100 at home. But I'm not sure what utilization rate going to be there for your hardware. So you already can do it. It's just not a lot of options for you for now.
Quite quickly.
Yeah, I'd just say at the end of the day, it's a market matching problem. So you have a certain value to your H100 at home, which is different to the value of an H100 in a data center with a load of interconnected ones. But somebody else in the world may value that at a certain point. The problem is the matching right now. So there's various front ends where, like Vast AI, where they will find the customers, and behind the scenes you can list your device. But the market's very, very fragmented. What we focus on is that much lower level layer of just saying, hey, your device is connected up in a standardized way. So is that data center with 1,000 H100s. Somebody else can come from the demand side and define what they're looking for, and you might service their needs. You would probably get a lower price than the person with 1,000 H100s, but to you, that's fine. You have no issue with that. So at the end of the day, there's just this huge kind of like market settlement layer that has to kind of close out. We focus on making it completely standardized at the software layer, and then there can be front ends on top which offer out the like enterprise grade access to hardware. There'll be other front ends which maybe look a bit like Google Colab, where they're designed to be on kind of less fault tolerant hardware, less reliable hardware, but they're lower cost, and maybe students use those. But we're very early in this market. Essentially, we need more people to build those front ends so that the demand will come to the decentralized hardware.
Okay, we're going to wrap it up. Thanks very much. Thank you.
Thank you.
Thank you.